All right, so here we go. Lecture number 1. This is going to be a review. Today is the 1st of February. Okay. So we're going to be reviewing particularly topics from Math 115. So college algebra, right? A lot of things in college algebra can be summed up. We can sum college algebra in Math 115 in pretty much in 3 bullet points. Very good, Phil. So the first thing is you pretty much learn 3 skills in Math 115, and that's simplifying. You learn to simplify nearly everything, right? Simplify what? Simplify exponential expressions, right? We did exponential expressions. Sorry, I should just include everything right away. We did exponential radical polynomial, rational expressions, right? So we learn how to simplify a lot of things. We also learn how to factor. Factoring is an extremely important skill, factoring. So we did factoring what? We did binomials, right? Trinomials, and so on and so forth, the polynomials. So we learn how to simplify things. We learn how to factor things. And we also learn how to solve. So these are like the 3 major skills that algebra gives you. 3 major skills. And these 3 major skills are utilized for the rest of your mathematical career. You're going to be simplifying things all the time, factoring as much as you can, and solving equations. So solving, what kind of equations though? Well, you've done linear, obviously. It's like the first kind of equation you solve. You talk about quadratic equations. We also talked about rational radical equations. Polynomial ones, the ones that you could, that are possible to solve. So again, Math 115 can be condensed into these 3 major skills. So let's start with seeing how good your factoring skills are. So let's look at factoring for now. So this is just examples, right? I want you to factor 12a to the 4th b minus 27a squared b cubed. So first of all, can anyone tell me what factoring technique? So within factoring, there are several kinds of factoring techniques that we apply. So what factoring technique are we applying for this example? So that's right. We're dividing it by 3, but what's the technique? What's the factoring technique called? Very good. Very good. So my technique is GCF, otherwise known as greatest common factor. So you need to find the greatest common factor between these 2 terms. So the greatest common factor would be what? So what do they have in common? They have a 3 in common, right? What else do they have in common though? Not just a 3. They both have A's in them. So how many A's can you factor out? What kind of A do you factor out? A squared. That's very good. So A squared. And how about the B's? How many B's am I going to factor out? Right, I'm gonna do b, just one b. So 3a squared b, that's my GCF. And again, guys, this is a review, okay? So these are things that we expect you to know. So the GCF is 3a squared b, and what happens? The 3a squared b is placed on the outside, put parentheses, and what's left in the parentheses? So if I take out a 3a squared and a b from the first term, I get a 4a squared, correct? It's 4a squared, not just 4a. And then when I take out the 3, I get a minus 9, and I get a b squared. Everyone agree? So all I did was, this is my GCF. And I factored it out. But did I completely factor this? In other words, can I factor this once more? Is there more to factor? And there is. What kind of binomial is this here? Does anybody know what this is called when you have this kind of two terms subtracted by one another? That's right, Cindy. That's right. This is a difference of perfect squares. So not only do we so I guess here we can say technique number 1 is GCF, and now technique number 2 is difference of perfect squares. So the difference of perfect squares looks like this: a squared minus b squared equals a plus b, a minus b. So you guys need to know how to factor using the GCF, and you guys need to know how to factor difference of perfect squares. So this is the difference of perfect squares. So we got 3a squared b. And does anybody know what's the results of this? When you factor 4a squared minus 9b squared as a difference of perfect squares. And again, you guys can speak out loud if you need to. But what is the... No, you're right, Phil. It's exactly right. So it's 2a plus 3b and 2a minus 3b. And we're done. So this, guys, is the fully factored form of our original expression. So we apply GCF first, and then we apply the difference of perfect squares factorization second. Is everything okay with this?
Yeah.
Yes.
Yeah.
Good, good, good. That's what I expected. Okay, good. So now let's look at the next example. What if I get something like this? 10x squared minus 25x minus 60. So this is what's called a trinomial, right? Particularly, it's a quadratic expression, but it's a trinomial. Now, what's the first thing again that I could do here? So always see if you can factor the GCF. Is there a GCF among these three terms? Right, the GCF is 5, right? So let's take out the GCF. So I got 5 parentheses, and then what am I left with? 2x squared minus 5x minus 12. All in agreement? So this is my GCF. Okay, so I took out the GCF, but now what's left? I still have a trinomial left. Now, does anybody remember or recall how to factor a trinomial that's quadratic in nature and has a number in front of the x squared. How does one factor such a trinomial? There's a particular method people like to call this the X method. I'm not too aware of the X method. It's called the AC method. Does anybody recall this?
You multiply 2 and 12.
Right, you multiply 2 and negative 12.
Right, yeah.
So the A value here is 2 because the A value, where does this come from? This comes from this expression, ax squared plus bx plus c equals 0. I mean, no, you can just, you don't need the equal 0. But it comes from this idea that the number in front of the x squared, it's known as my A value, and the number without anything attached to it is the C value. So A equals 2 and C equals negative 12. What do? You multiply A and C and you get what? Negative 24. And then what's the question we ask ourselves? So after we multiply 2 and negative 12, we get negative 24. Then what do?
What pluses or minus to -5?
Very good. So then you have to ask yourself what two numbers multiply to negative 24, and when you add them up, give you negative 5. So what are those two numbers? So what are the factors of 24? Factors of negative 24 whose sum equals negative 5. So what are those factors?
-8 and 3.
Negative 8 and 3. Negative 8 times 3 gives you negative 24. Check. That's the first criteria. The second criteria is that negative 8 plus 3 gives me negative 5. Check. So what does that mean? 8 and negative 3 are those numbers. Negative 8 and positive 3. Now that I know that the correct numbers are negative 8 and 3, what am I going to do with negative 8 and 3?
Don't you have to put them into two different parentheses? Like 5 and then two different parentheses?
Right, I'm going to get there eventually. But the thing that what I do first is I rewrite negative 5. I use negative 8 and 3. So negative 5x, I can write this as negative 8x plus 3x minus 12. Does everybody see that? So let me highlight this. This guy here, negative 5, becomes this. Negative 8x plus 3x. So then you're like, wait a minute. We just made this more complicated because now we have 4 terms instead of 3 terms. What are you doing, right? But actually, this helps us a lot. Why? Because look what we're going to do next. We're gonna do what's called factor by grouping. So the AC method requires you to understand factor by grouping. So this is the first technique here, and the second technique here is factor by grouping. So the first group we factor, the second group we factor, and we factor what? Using the GCF. So what can I factor from the first group? 2x squared minus 8x. I can factor A.
2x.
A 2x. And that becomes x minus 4. Do you see that? And then I can factor from the second group a 3. Does everyone see that? I factored each group individually. And then what do I notice that's the same? There's an x minus 4. There's another x minus 4. So what can I do now with this x minus 4? I can factor the x minus 4 expression out as well. And so the result is what? 5 multiplied by x minus 4 multiplied by 2x plus 3. And this is my final factored form. Any questions about this? So again, this is review, just to get our feet wet, and we start by factoring. Again, factoring is an essential skill. So far we've covered GCF, difference of perfect squares. We talked about the AC method, which involves utilizing what's called the factor by grouping technique, factoring technique. So any questions about this? Clear? Does everybody understand how each step is going back, each step one by one? No questions. Okay, great. Great. And I'll give you, let's do one more of these factoring. Let me see if oh no, I should use a different color here. The next one is this one, 5PQ plus 15PR minus Q minus 3R. So I want to factor this. This has 4 terms. Whenever you have 4 terms, always try to think that there might be a factor by grouping possibility. Because when you have 4 terms, you can group them into 2 groups of 2. This may or may not work, and in this case, it's going to work. So I look at the first 2 and the last 2 and create 2 groups. And then for the first 2 terms, I'm going to factor out the GCF. And what can I factor from the first group? What's the GCF for the first 2 pairs, the first 2 terms? A 5 and a, you're missing something, 5p. There we go, Judy. That's right. So 5p. So I can factor out the 5p, and I'm left with a q plus 3r. Good. That's the first group. Now, what about the second group? What can I factor from the second group? I got a minus q minus 3r, right? It's a negative one, guys. We factor out the negative one. So there's going to be a negative one, and this becomes positive q plus positive 3r. And you see how this works now? Because I did this, look what happens. I got the q plus 3r and the q plus 3r in both terms. Because that's the case, I can factor that out. And I'm left with q plus 3r, parentheses 5p minus 1. And I'm done. Finito. So again, this is just factoring, reviewing, factoring by grouping, AC method, difference of perfect squares. Okay? And there's definitely a few more things to go over that I would like to go over. All right. So any questions about factoring? We're good? Okay, good. So factoring, we're good. Okay. How about let's go to the simplifying world. I know we only have like a minute left, but we can continue with this next time on Wednesday. So let's start simplifying. So does anybody know what this expression here is called? When you have fractions within fractions. It's a particular kind of fraction. It's not a simple fraction, but a
Complex.
there we go. That's right. So we have complex, and there also some textbooks call it compound. Compound fractions. So this is a kind of expression, not just in pre-calc, especially in calculus when you talk about limits. You're going to be wanting to know how to simplify complex compound fractions. So we'll stop with this for today. Let me just